Welcome to this session on code coverage, covered in depth, or what some people call it, whatever you wanted to know about code coverage but never got the chance to ask. So hopefully after this talk there's no question anymore what you can do with code coverage in PHP Unit, and you'll also know a little bit about what's coming up in the future of this really exciting area of features in PHP, PHP Unit, and unit testing in the PHP world. So, hi, my name is Sebastian, and for a really long time I've now been doing things with PHP and to PHP. I started working on PHP Unit a little bit over 15 years ago, and got involved with PHP like 2 years before that. So that's a really, really long time, but it's still fun. So, and I like to build tools that help developers build better software with PHP. That's what I'm very passionate about, and that's what I also do in my day job. No worries, no marketing, just at the fact that I like to share my experience with other developers and help teams build better software. What is this talk about? So a couple of years ago, I read an interesting book called Beautiful Testing, and it had one chapter on code coverage, which is a topic or a subtopic of testing that has always fascinated me. And in the very beginning of this chapter, the author writes, the beauty of testing is not found, is found not in the effort, but in the efficiency, and knowing what is being tested is very beautiful. So getting more information about while the tests are running of which parts of my code are already being tested and which parts are not tested, and that is really useful information. And of course, there's a much more formal and drier explanation or definition, if you will, of what code coverage is. So if you look at Wikipedia, for instance, you'll find that in computer science, code coverage is a measure used to describe the degree to which the source code of a program is tested by a particular test suite. A program with high code coverage has been more thoroughly tested than one with a lower code coverage, and the idea is that if you have a high degree of code coverage, then it's less likely that you have bugs in the code base that you're not aware of. So I already mentioned that code coverage is something that has fascinated me for a long time, so let's start with a look in the past. And is he here? Is Derek here? No, he's not here, so I can talk about him. Damn, it's recorded, he can watch the video. So, okay. Anyway, for a long time, I don't remember when I started bugging him about implementing that. I wanted to have this feature for PHP, and for a long time, PHP did not provide the raw data that is required to figure out which lines of code are actually executed by the PHP runtime while a particular test is being executed by PHP Unit. In 2003, with the release of Xdebug version 1.2, Xdebug introduced support for code coverage. And around that time, I made the first attempt of doing something useful with that data in PHP Unit, and that was my first attempt. And yes, I'm aware that it's very, very ugly. And it was also not very useful because for your entire code base, it generated one huge HTML file with all the source code of all the files, one after each other, highlighting which line of code was executed, but not any information in there which test was responsible for which line being not even green, but gray. But this was just a quick first implementation of trying to do something with the data, because Derek had just implemented it in Xdebug, and we had no way of visualizing that data to begin with. So we needed one first quick solution to actually see whether or not the data that we get makes sense. So that was the whole purpose of that. And it was not really a problem that it looked ugly, because at the time, nobody was using it. But what surprised me, that 9.5 years ago, I wrote this first piece of PHP code that did something with the data that comes out of Xdebug, and it still runs unchanged without a single error or warning on PHP 5.6. So that's kind of cool. And before it got less ugly, it became even more ugly, but at least we had one separate HTML file for each PHP source code file. And that was PHP Unit 3.0, which came out in 2004, on the same day that PHP 5.0 came out. So that was a big step forward. Was much more usable. There was information how often a line of code was executed in the report and so on. But it was still lacking some sort of more advanced metrics. But still, that didn't matter, because nobody was using it, or at least not a second time, because it was so slow. I remember at the time that this came out, Derek and I were working at the same company in Norway, living close to each other, and hey, and there he is. Hello. And it was so slow that for the test suite that we were working on, without code coverage, running this test suite took like 4-5 minutes on our notebooks. Running it with code coverage enabled took like 12 or 13 hours. That was the slowdown that happened while Xdebug, in the first iteration of this code coverage data collection feature, incurred, and that you had to live with. And I remember that at some point in 2007, I ran into Derek at a conference, and he had just gotten off the plane, and he said, I did something stupid a couple of years ago. I think it was at ZenCon 2007. And just on the plane over here, on the flight to get here, I fixed this, and now it's faster. So the slowdown from the earlier versions of 4 minutes versus 10, 11, 12 hours went down from, well, basically went down to 10 minutes or so. So I don't know what he changed, or I don't remember what he changed, but it had a huge impact. And he's going to look it up. He can't remember either. That's how old we are right now. In 2009, I took all the code that deals with code coverage and took it out of PHP Unit, put it into a separate open source project so that other testing tools in the PHP world could reuse that. And that's called PHP Code Coverage. And that's basically what we have today. So what we have today is PHP Code Coverage 2.0, which came out alongside PHP Unit 4 last year. It has several drivers. One of those drivers is going away soon, apparently because it's no longer needed, the HHVM driver, because newer versions of HHVM don't have their own API anymore. They emulate Xdebug's API, so I don't need a separate driver, which is good. PHP Code Coverage not only uses Xdebug to collect the raw code coverage data, but also does some processing of the data and calculates various types of code coverage metrics that you can use. So we get line coverage, function and method coverage, class and trait coverage, the CRAP index, which has a really funny story behind it, and something called patch coverage. And then there are different front ends, if you will, that can take this data and render it in various formats. What's most commonly used is the HTML report and the one or more of the XML log files that are, for instance, consumed by a continuous integration server such as Jenkins or Bamboo that visualize code coverage data over time as it changes from build to build. So what are all of these metrics? The simplest code coverage metric there is line coverage. If you have a source code file, then the source code file has multiple source code lines, and not all of those lines are executable, but of those that are executable, you can calculate what the percentage is of lines of executable code that are executed while the test suite is running. And if all of those lines that are executed, then you have a line coverage of 100%. And this is how this is visualized in the HTML report, for instance. And I hope you believe me if I tell you that this is supposed to be green and this is supposed to be red. So for each line of code, there can be one of four states. The line can have no background color at all, which, for instance, is the case for lines 125 through 133. So if it's not highlighted at all, that means that this line of code is not executable. That does not mean that this line has no purpose. It just means that it's not relevant anymore at runtime. This could, for instance, be embedded HTML or a code comment, or it could be a class or method declaration that is relevant at compile time, but not when the code is actually running. A line can be red, meaning this line of code is executable, but not a single test of the test suite has executed this line, so this line of code is currently not being tested. It's uncovered. A line can be green, meaning this line of code is executable and was executed by at least one test. So it's to some degree tested. More on that in a little bit later, why line coverage is not a sufficient metric. And last but not least, a line can be highlighted in yellow, meaning this line of code is executable, but it cannot be reached. So it's dead code. And there are two kinds of people. One that get confused if they don't see that code in the code coverage report, and those that get confused when they don't see it. And this is one of the very few cases in the development of PHP Unit where I decided to be egoistic. I get confused when I don't see this information because I know what the underlying data is and what it means, and I want to see when there is that code. And the most common case where you see that code is, or one of the most common cases, is the closing curly brace of a function or method. Because the closing curly brace of a function or method is compiled by the PHP engine into a return null statement. And if you have an unconditional explicit return statement right before the closing curly brace, the implicit return null statement on the next line, yes, it is executable, but it cannot be reached, so it's dead code. That's the only thing about that code. Okay, so that's just one visualization of line coverage. At some point a couple of years ago, I got a pull request that added a text-based output or visualization for code coverage. I personally have never used that. Some people find that useful if they host their open source project, for instance, on GitHub and run their unit test suite on Travis CI and want to see code coverage information on Travis CI without using yet another cloud-based service such as Coveralls, for instance, which would visualize the code coverage information using HTML reporting, for instance. Some developers just want, while they're working on one class, want just to run the test for that one class and see on the command line really quickly the code coverage for that class. I can understand that, but it was never a use case for me. But the whole point of the design and architecture of the PHP code coverage component is that if there is a use case for some sort of visualization of the data, then it can be added. It's so flexible that you can just add it, and some people, if it's useful for some people, then that's awesome. What's more commonly used is the various XML log file formats. For instance, the Clover XML format. Clover is a commercial tool in the Java world and the de facto standard for code coverage tooling in the Java world. And at some point, they defined their XML log file format for storing code coverage data, so that tools like Jenkins or Bamboo or other tools can do something useful with that data. And the good thing about tools like Jenkins and Bamboo is that they don't care which piece of software created this log file. So when I when I wanted to add XML logging for code coverage data to PHP Unit, I implemented the Clover XML log file, and Bamboo or Jenkins do not care that this log file was not generated by the Java runtime and Clover, but by PHP and PHP Unit, and they can just visualize it, which is really cool. You can also tell PHP Unit to store the code coverage data as PHP code, which is really convenient and especially has interesting performance aspects because it's really, really quick to parse that compared to the XML data when you want to do something with the data, some pre-processing before you actually visualize it. People usually use that if they split up the execution of their test suite, for instance, to run it on multiple different platforms. So if, let's say you are a vendor of a product that should be tested on Linux and on Windows machines, then you run your unit test twice, once on Windows, once on a Linux machine, and you want their code paths in your application that are only ever executed when you're on Windows, and there's code that's only ever executed when you're on Linux. And if you run it on Linux, then you would never ever get code coverage for the code that's only useful and used on Windows and vice versa. So you run it twice, you get the data for both runs, and then you can merge it. And there's tooling for that. There's a command line tool called PHP COV that comes with PHP Code Coverage that allows you, for instance, to merge the code coverage data from multiple PHP Unit runs. And another use case for that is if you split up your test suite so that you can run your tests in parallel, for instance, then you also want at the end a unified code coverage report. And that's what this allows you to do. And this is like the simplest way of running a PHP Unit test suite in parallel. You partition it, you use the command line tool parallel to run multiple instances of PHP Unit in parallel, and at the end you merge the log files using PHP COV. If we abstract or raise the abstraction level a little bit while looking at the source code and looking at code coverage, the next thing that we could look at would be function or method coverage. If I have a function or a method, then that function or method consists of multiple lines of PHP code. So a function would be considered as being covered when its code is executed. And depending on which text you read, there are different interpretations of this metric. The weakest definition says if there is a function, and if this function is called or invoked at least once while the test suite is running, then this function or method is considered as being tested. That's too weak for me. So when I implemented this for PHP Code Coverage, I said, no, I want the strictest definition of this metric and only consider a function or method as being covered when all of its executable source code lines are at least once executed. One level up, you have class or trait coverage. A class has multiple methods, and if all methods of that class are covered, then the class is considered covered. And we have the same situation as with the function and method coverage. The weak definition says if all methods are invoked at least once, then the class is covered. Well, same applies. If everything is covered, then if all the lines of all the methods are covered, then the class is covered. In the HTML code coverage report, this data is visualized. So you have, for instance, a column for the lines and for the functions and methods and the classes and traits. And this is the directory view, where we see, for instance, the code coverage.php file, which has 232 executable lines of code, out of which 164 are actually executed while the test suite is running, making for a 70% line coverage. There are 24 methods in that file, 15 of which are completely covered. There's one class in that file which is not completely covered, so 0%, because not all of its methods are covered. Again, very strict interpretation of the metric. The crap index. Already mentioned it earlier that there's an interesting or a funny story behind it. So once upon a time, there was a Java consultant that came into a company for a code audit, and at the end of the day told the developers, your code is crap. And the manager said, why is our code crap? And the consultant said, well, I'll explain that to you tomorrow. And the consultant goes back to his hotel room, thinks about this a bit, sleeps over it, and the next morning implements a new tool, comes back to his customer, runs the tool, and says the tool says your code is crap. And what he did was overnight he came up with the crap index. And only later on he looked for 4 words that would abbreviate to crap. So it's the change risk anti-patterns index, which is a metric used to measure the amount of pain that you as a developer will feel when you change a piece of software. And what he did there was really clever, because he takes 2 other well-established software metrics and just combines them. So he takes the cyclomatic complexity, which is the oldest and most simplistic software metric that we have for measuring the complexity of a piece of code by simply counting the number of branching points, like if, for each, while, case, catch, and, or, and the ternary operator. And I think starting with PHP 7, we will also need to take into account the, what was it called again? The coalesce operator, yes. Okay, so you count all of the occurrences of these operators in a piece of code, and then you get a number, and that number is the cyclomatic complexity. And then he came up with this formula where he puts in the cyclomatic complexity and the code coverage of the unit of code and calculates the crap index. And the higher the crap index, the more pain. And pain we don't want to have. Pain leads to suffering, and so on. So code that is not too complex and has an adequate test coverage will have a low crap index. And the crap index can be lowered by either writing more tests, if I'm not at 100% already of code coverage for that unit of code, or by refactoring the code to have a lower complexity. And in the HTML report, this is where you find the crap index. You'll also see it if you, it's not on, if you click on this dashboard link, then you get to this view in the code coverage report. And I have no idea why, but like every so often I run into a team that never knew that this dashboard thingy was a link and could be clicked, and that there's this wealth of information hiding behind it. Lots of useful information there. For instance, an overview of how complex your classes are and what kind of code coverage distribution you have. So for instance, in this project, there are 25 classes that have 0% code coverage, and a couple of classes that have 100%, and then a mix between there. There's a tabular view with project risks or a list of classes that have insufficient coverage. So this is a good thing to look at if you as a developer don't know what you are supposed to be doing right now because you finished all of your tasks in the sprint, or some teams that I know have a specific day, like for instance every Friday afternoon they work on code quality, like write tests for areas of the code where tests are missing just to improve the quality. And they look here to see, okay, this is a very important class that is very risky to change at the moment because it's too complex, so I need to work on that either by refactoring it to make it less complex or by adding more tests to it to lower the crap index and to reduce risks in the project. And the same kind of data, not just on the class level, but also on the method level. There's another code coverage metric that's really interesting called patch coverage, which measures whether each executable line that is changed by a patch is tested. And this is a brilliant way of establishing testing in a legacy code base. If you have a legacy code base that is a couple of years old and has a couple of tens or hundreds of thousand lines of code, you will not get to a decent level of code coverage overnight. It will be a long and most of the time very painful road to get to where you want to be. But it's not too hard to establish a rule that starting from today, I want to have a specific degree of patch coverage. Like I make a commit, I change 10 lines of code and add 20 new lines of code, can make sure using patch coverage that this new code that I add is actually tested. And then over time, start adding tests for the existing code. And this is a feature provided by the PHP COV command line tool that I mentioned earlier. It takes as input the code coverage data from a PHP unit run and a diff that, for instance, comes from your version control system. And it figures out which lines of code were changed and if there are tests that cover this line, and in the end tell you, okay, this patch changed 2 lines of code, only one of which was covered by a test, and this is the line that was changed that is not covered by a test, do something about it. And this is something that you can integrate into your continuous integration, for instance, and have Jenkins, for instance, run this for every change to version control to your project and get an idea for where your patch coverage is. Of course, in a clean, new, modern project, you probably won't need this because you're going to be very close to 100% code coverage anyway. So, but still, it could be useful there as well. So that's how we collect code coverage information and how we can present it, but there's a lot of configuration things that we can have a look at. And the most important thing, or the most common thing that most people configure, is which files do I want to have show up in my code coverage report. So by default, all source code files that contain at least one line of code that is executed while the test suite is running show up in the code coverage report. Of course, that would also include the source code files of PHP Unit and its dependencies, which you are not interested in. And of course, it also includes the source code files of your libraries or frameworks that you are using in your application, and you're also not interested in code coverage for those. That's why you can configure which source code files show up. By default, a blacklist is used to exclude files from the code coverage report that belong to PHP Unit, for instance. So by default, a blacklist is used, and by default, this blacklist is pre-filled with PHP Unit's own source code files and the source code files of PHP Unit's dependencies. However, it is a best practice to configure a whitelist. Tell PHP Unit, here is the one directory for which in which I'm interested in, like your src or app directory or your library directory or whatever. You can configure as many directories as you want. Usually, it's just the top level directory of your own source code without your dependencies. And if you configure the whitelist, then only the files from the whitelist show up in the code coverage report. Blacklisting is not used then. So if you configure a whitelist, the whitelist is used. If you don't configure the whitelist, the blacklist is used. Using the whitelist is encouraged in best practice. you can set an additional configuration option so that all whitelisted files show up in the code coverage report regardless of whether or not they're touched by the test suite. And consider a situation where you have, I don't know, a couple of hundred or 1,000 source code files you start testing, and you whitelist, you configure a whitelist, like this is the directory where my 1,000 files are, and you write your first test. And your first test only executes code from one class. And PHP Unit would only see that one class because the other code is not touched. Then PHP Unit would generate a report for you that says you have 90% code coverage, which is true for this one file. But you have so many more files that the tool doesn't know about unless you tell it to look for all the files, even those that are not tested yet. So this is why you can turn this on. Starting with PHP Unit 4.7, which is due at the beginning of June, there will be a warning if you don't have whitelisting configured. Because I still come across so many teams that have not configured whitelisting, and I want to give them a friendly slap on the wrist. Configure a whitelist. It takes 5 seconds. It's not hard to do. Do yourself a favor and do it. And maybe if I tell them, or maybe if the tool tells them every time they run the tool, eventually they will actually do it, hopefully. Talking about PHP Unit 4.7, there's one, I wouldn't really call it new feature because it's just one additional line that you see in the output at the beginning, but still, I think it's useful. And many people find it's useful, that it prints some information about the runtime that is used. Again, this could be viewed as me being very egoistic, because I hope that when somebody files a bug report for PHP Unit on GitHub, they will completely copy and paste the output and have the information with which version of PHP and xdebug it was run. But also, if you have multiple versions of PHP installed and run the tests with multiple versions of PHP, very useful to see this is the version of PHP that it's being run. Also, there are at least 2 or 3 bug reports every month for PHP Unit where people say, okay, I run this, and when I run it without PHP Unit, it works, and if I run it with PHP Unit, it doesn't work. I get weird syntax errors. And in all the cases where this happens is that for some reason their PHP Unit installation uses an outdated version of PHP that they have lying around on the hard drive somewhere. So just 1 or 2 weeks ago, somebody reported an issue like that, and they were using PHP 5.5 syntax, but somehow PHP Unit was using PHP 5.3. And they were not aware of the issue because it was not printed. So that's the reason, or one of the reasons behind why this line is there. Okay, bless you. Talking about configuration. So of course you can do some things in the XML configuration file, but you can also do some stuff in the code itself using annotations. This is probably the most abused annotation that PHP Unit supports. Just like the most commonly abused annotation that PHP Code Sniffer or PHP Mess Detector supports is ignoring the whole file. But sometimes it's useful. Let's say you have a class or a method that you only need on one specific platform. Like what I mentioned earlier, you have a product and you want to run a test for the product on Linux and on Windows, but you don't want to invest the effort of running the test suite on both systems. You say, I only care about Linux, don't really care about code coverage report for Windows, but I don't want to have the Windows-specific code, which I never execute on Linux, make my code coverage percentage bad, so you want to exclude that piece of code. That's a valid use case for this annotation. it's not a valid use case to use this annotation to make your management believe that you write code that is 100% covered. And I actually experienced it a couple of years back when I came into a company to do a test review for consulting, and I figured out that there were quite a few source code files in the project that had, well, that basically ignored all the code from code coverage. And I started asking the developers, why is this? Because this code, it's not platform specific, and in fact it's critical to what the application is supposed to be doing. So why are you ignoring the code from code coverage? And the developers got very angry at one specific team member. And it turned out that a couple of months before, there was an incentive from the team's manager that said basically the developer who has the highest code coverage in the new code that they produce within 2 consecutive sprints or something, forgot the details, gets a bonus. And the bonus went to the person who knew that this annotation existed, which was not nice. So that was not my intention when I added this annotation to PHP Unit. And at some point, I need to add a command line switch, probably that forces PHP Unit to ignore this for certain situations. PHP Code Sniffer and PHPMD already have that. But then again, I don't really. You cannot solve social problems like that with a tool. It doesn't really work. So you can use this code coverage ignore annotation on the class level, and it will ignore all the source code lines of that class. You can use it on the method level and ignore only the lines of code of that method. You can also use it within the scope of a method, for instance, or on a smaller scope on the line level, by using code coverage ignore start and code coverage ignore end, and everything between those 2 lines will be ignored. Sometimes useful when you have things like exit, and during testing you don't hit the exit for whatever reason, and you want to ignore it. If you just want to ignore one line, you can also add the suffix / code coverage ignore to the end of the line and just ignore the line. Just a shortcut for this. Sometimes comes really handy. A really powerful annotation is the covers annotation that you can put into or onto your test methods. And this tells PHP Unit that for this particular test, you are only interested in code coverage of a specific method or multiple specific methods or of a specific class or other units of code. So in this case, in this example, it says we are only interested in code coverage for the construct method of the money class. And if there is other code that is being executed while this particular test is running, ignore the code coverage. I'm only interested to generate code coverage from this test for this particular method that I'm interested in testing. And of course, there has to be a strict mode setting for that. So the story behind strict mode in hopefully a minute or less. Like a couple of years ago, I also doing test reviews, I saw that there were many weird tests out there that didn't really test anything or test the wrong thing or tested the right thing in the wrong way. So I started adding strict checks to PHP Unit. People outside of Germany usually say this is the German mode for PHP Unit, and I should rename it to German mode and not strict mode. My answer to that is I don't know whether it should be called German mode, but in my opinion it should be the default and not something, an option that you could turn on. But then again, I'm German, so. But anyway, with rollback. Last year with PHP Unit 4.0, or by the time PHP Unit 4.0 came out, strict mode had grown so much that there were so many different things that this one configuration setting was responsible for, that I split it up into granular configuration options so that you can pick and choose which checks you want to have. And one of these checks is strict coverage. And what strict coverage does is, if you have a test like this one that says, I'm only interested in code coverage for this particular method, what happens in strict coverage if such a test executes other code than what you're interested in, it will mark this test as being risky. And it will tell you, I consider this test to be risky because it executed code that it did not expect to be executed. So it's not a failure, it's not a success, it's just, this looks wrong to me. You told me explicitly that with this test, you're testing this method, there's other code than you're interested in running while this test is being executed. Have a look at this. And one way of resolving that situation is to tell PHP Unit it's okay that code of this particular other method, because it's from a collaborating object, for instance, that for this particular test case I do not want to stop or mark, is being executed. And then it will not show up in the code coverage report, at least not in the code coverage data yielded by this test. But it will also not yell at you in strict mode because you expect this to be used. Classic example for collaborating objects that you do not want to stop or mock are value objects, like a currency object in this case. And this feature is the kind of stuff that happens when at least I am bored on a train or a plane. I think it was a train in this case. And I wonder about things like, okay, I have this information with the covers annotation that this test is interested in this unit of code. And using the information from the uses annotation, I know that this unit of code that I'm testing uses this other unit of code to do its job. So can I do something useful with that data? I'm still not sure if that is useful, but it served the purpose of making a boring train ride less boring. It took me like 1.5 hours or so to implement, parse the code base, look for the annotations, build the data structure, and then visualize it using GraphViz. I haven't touched the code since. It's available on GitHub. If you think that this could be useful, you're welcome to use it or to build upon it or whatever. It was useful for me to pass the time on the train. Still not sure whether or not it's actually useful, but it kind of looks cool. So this is the money test class, for instance. This is one particular test in there, and that one is interested. So that one is boring, but this one is for the multiply method, and multiply collaborates with something over there. Okay. Yeah, so that tool is called Testmapper. We are getting close to the future. This is not out yet, but it will be out in 2 weeks or 2 or 3 weeks, so it's not really the future. It's basically already there. You can use it today if you want. It's in beta. So PHP Code Coverage 2.1, small feature release before the big feature release that's going to happen also hopefully soon, but not as soon as 2 or 3 weeks from now. It's part of the PHP Unit 4.7 release cycle. PHP Unit 4.7 will come out on the first Friday in June. If you're not familiar with PHP Unit's release model, every 8 weeks there is a new feature release, and it's always on the first Friday of a month. So first Friday of June is the next one. And there's one new feature in there that uses the information from the small, medium, and large annotations that PHP Unit already has. They are currently only used by another strict check. So if you enable that strict check, then a small test is only allowed to run for 1 second or so, or a couple of milliseconds. I forgot the default threshold. And the medium test is allowed to run longer, and then a large test is allowed to run even longer. At some point in the hopefully not so distant future, there will be another strict check that operates on small, medium, and large. And for instance, a small test will then be aborted when it touches the file system, for instance, or talks to the database, because that's not a small test, that's a medium or large test. But we'll do something with that data in PHP Unit 4.7 and introduce different shades of green in the LineCoverage report. So consider this really, really stupid example of PHP code. We have one class named example and 3 methods, 1, 2, and 3, and all do the same. And let's just assume, for the sake of the example, that we have 3 different tests. One is marked small, one is labeled medium, and one is labeled large. And I don't see, from looking at this code coverage report, whether or not a particular test is covered by a real unit test, or if it's just covered by an end-to-end test that tests through the user interface, for instance. And what happens if you run this same test with PHP Unit 4.7, it will use different shades of green. The darkest shade is this is covered by a test that is marked as being small. So hopefully meaning that this test is actually more valuable than a test that is labeled as large. I'll talk, by the way, in my presentation tomorrow, I'll talk about all the different kinds, shapes and sizes and scopes of tests, and maybe we'll cover that from a different perspective then. So future. Remember at the very beginning I said that it took me a while, like over 10 years ago, to convince Derek to implement code coverage originally. And I was very thankful when he finally did that. And for about 10 years we only had LineCoverage for PHP and PHP Unit. And I looked into my mail archive earlier today, and sometime around late 2010, early 2011, I started bugging him again to implement branch and path coverage. The last time I bugged him about this was last year in February in Montreal at Confu. And he promised to have branch and path coverage implemented by the end of the year. And that worked out, right? 2.3 came out before the end of the year, right? Or was it on? No. February, yeah, but the feature was implemented before that. Anyway, doesn't really matter because it's there now. At least in Xdebug. So unfortunately, we cannot use it in PHP Unit yet because PHP Code Coverage 3.0 is not out yet. So what PHP Code Coverage 3 will add is doing something useful with the branch and path coverage data that Xdebug now provides. So on top of line coverage, we will get branch and path coverage. Branch coverage measures whether the Boolean expression of each control structure evaluated to both true and false while running the test suite. That's not really interesting. Yes, it's more granular than the line coverage, but what we're really after is the path coverage, which measures, need to drink some water, but I'm too lazy to get over there, and it's also, I only have 5 minutes left or so, so let's get over it. So measures whether each of the possible execution paths in a function or method has been followed. And an execution path is a sequence of decisions that I take at the various branching points. From entering the function or method all the way until when I exit it. Sounds complicated. It's actually really simple. If you have again, stupid example, you have 3 consecutive if statements: if condition 1, do something; if condition 2, do something; if condition 3, do something. Question: how many unit tests do I need to yield 100% line coverage for this code? 8, 1, 9, 3. Come on. Line coverage. How many unit tests do I need to yield 100% line coverage? 1. You just wanted to yell something. Okay. So 1 is actually the correct number, because if I execute this in such a way that all 3 conditions evaluate to true, then I have the 100% line coverage. So if I set condition 1 to true, condition 2 to true, condition 3 to true, and so on, then I have 100% line coverage. How many tests do I need to get 100% parse coverage? 8. Why?
Because you could change the value of the next one.
I liked his answer better. Can you repeat? 2 to the power of 3, yes. Because up until this point, I have 2 possibilities of exiting this code. I can go in there or I cannot go in there. Here, I get 2 new choices. I can go in there, not go in there. 2 times 2 is 4. Same again, 2 times 4 is 8. And it gets even more interesting if those were nested. You can visualize that using a so-called decision tree. And we have condition 1, which can be true or false, and depending on blah, 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 blah. And then we have the leaves. We have the 8 leaves. And if we only run the 1 test that we had earlier to get 100% line coverage, that's only 1 out of 8 possible paths that we can execute this code, which is kind of poor. I had 100% before in that 1 metric, and now I have 1 out of 8. Question is whether we really need 100% parse coverage in all circumstances. There are industries where 100% path coverage used to be demanded by law or regulation. And since then, they moved away from parse coverage because it was too strict to something that is a little bit less strict. But still. And I'm not sure if we need that kind of strictness in the PHP world, depending on what kind of application you build. But we'll see what we can do with it once we have it. And at some point later this year, we will have it. So Derek already implemented it for 2.3. I'm currently working on support for branch and parse coverage in PHP Code Coverage in a branch. Once that branch is ready, it will be merged to master, and then after a probably 2 months stabilization cycle, release it as PHP Code Coverage 3. So hopefully around October or November, we'll have it, if not earlier. Depends on how much spare time I get in the next couple of months, and whether or not I decide to spend that spare time on this rather than on other stuff. So thanks for your interest in this. I think we have a couple of minutes left for questions. Those slides will be available as soon as I manage to export them to PDF and upload them. Actually been to conferences with far worse Wi-Fi than this one. So chances are that I might be able to upload them in the next couple of minutes. By the end of the day, they should be online. I'll tweet them, and otherwise you can find them at talks.thephp.cc. You can send me an email, find me on Twitter, or just ask your question now or during the rest of the conference. Any questions? Thank you. No questions? Then enjoy the hackathon or whatever social event is planned for tonight. Thank you.